Hi guys, today we are going to learn a shortcut trick to solve integration by parts, and we are going to use method which is called tabular method, and few people says it is Hindu method, and differentiation integration method. So let's solve integration x square cos 3x. So first of all, what you need to do, one side you write down derivative, and then other side you write down integration, and just draw a line in between. Okay, so let's see how it goes. So derivative will be x square, right? So let's write down x square. So derivative is x square here, and integration is cos 3x here. So we have written this under integration column and this under derivative column. So now let's do the derivation. X square differentiation is what? That is 2x. Then 2x differentiation is what? 2, and differentiation of 2 is 0. So you need to differentiate until you get 0. Now cos 3x, what will be the integration of cos 3x? So it will be sine 3x and divide by 3. Okay, now again integrate. So if you again integrate, so it will be minus 1 upon 9 cos 3x. Okay, and if we integrate again, so it will be minus 1 over 27 sine 3x. Okay, so now what we need to do, we will put here sign. So it is plus alternate sign, minus, plus, and minus. Yeah, now we need to multiply this into this, that is diagonally, then this into this diagonally, and this into this diagonally. We are not multiplying by 0, so because everything will be 0. So our answer will be like integration x square cos 3x is equal to, so first we are going to put plus sign here. So if you multiply this, so it will be x square sine 3x, right? So we are multiplying this and there's a plus sign here. So it will be x square sine 3x, and it is divided by 3. Okay, and it is positive. Next will be this minus sign and this minus sign, and minus becomes plus, and we are going to write down 2x divided by 9 cos 3x. So it will be, I'm writing here 2x divided by 9 cos 3x. Okay, and the last term will be this is plus and minus. Plus and minus becomes minus. So we are going to write down minus 2 over 27 sine 3x and plus constant, that is c. Okay, so it is c. So our final answer is, let's just simplify here. So if we simplify here, x square sine 3x over 3, so this is our answer. So let's write down here. So 1 over 3 x square sine 3x plus 2 over 9 x cos 3x minus 2 over 27 sine 3x and plus c. Okay, so this is our answer, right? This is our answer. Okay, in two steps. So remember, we are putting here derivative x square, then 2x, and then 2 until you get 0. Once you get 0, you need to stop, and then we'll put alternate sign, plus minus, and then multiply diagonally. So x square into sine 3x over 3. So x square sine 3x over 3. So we have written here Okay, you can see here x square sine 3x 3 we have written here, then 2x into minus 1 by 9 cos 3x, then we have written here, and then the third one is 2 times minus 1 by 27 we have written here. So this will be giving you answer, yeah, integration x square cos 3x. Now so let's take another example here. So another example, example 2. So let's write down here example 2. So that is x square sine 4x. Yeah. So let's take another example. Example 2, integration x square sine 4x dot dx. Okay, so same thing we are going to write down here. This is derivative, this is integration part, and just draw a line in between. So okay, so once you draw a line, so let's write down derivative. It is x square. Differentiation of x square will be 2x. Then differentiation of 2x will be 2. Then differentiation of 2 will be 0. Then similarly here, so this is done. Now this sine 4x. So let's write down here sine 4x. Integration of sine 4x is minus cos 4x divided by 4, then again we integrate it, so it will be minus sine 4x divided by 16, and next one will be it will turn into positive, so it will be positive cos 4x, and 16 times 4 is 64. Okay, so this is what we have done. Now what we need to do, we need to put alternate sign here. So it is plus, then it is minus, then it is plus, and then it is minus, and then we'll multiply diagonally, this into this, this into this, and this into this. So integration, let's write down the question here. So integration x square sine 4x into dx, that we can write down. So see here, first time plus sign and minus, it will be minus, and it will be x square over 4, and it is cos 4x. Okay, now similarly, when you multiply this minus and minus, it will be plus, so it will be 2x over 16 sine 4x. Okay, and the next one will be, if you multiply plus and plus, so it will be plus 2 cos 4x, so 2x over 16 sine 4x. Now it will be 2 cos 4x over 64. Okay, and then we'll put constant c. Okay, so we'll put constant c. So now, okay, so similarly you can simplify it. It is you can simplify it. It is 1 over 8, and it will be 32. Okay, so your final answer is minus x square over 4 cos 4x, and here it will be x over 8 sine 4x plus 1 over 32 cos 4x and plus c. So this will be your answer, right? So this is the way we can solve it using tabular method. Yeah. Now let's see another example. Yes, so this question is really different, because if you see here, it is e to the power 2x and cos x into dx. Yeah, so we'll follow the same method, that is d and I, and let's do the derivative in between and integration. So what happens here, if you see, derivative is e to the power 2x. Okay, and then this part which we need to integrate, that is cos x. Yeah, okay, now integration of cos x will be minus sin x. Let's write down here minus sin x, and derivative of e to the power 2x will be 2 e to the power 2x. Yeah, if we do it again, differentiation of this, so it will be 4 e to the power 2x, and integration of minus sin x will be cos x. Yeah, so integration of sin x will be cos x, and there is a minus sign, so it will turn into positive. That will be positive cos x. Yeah, so cos x, then minus sin x, then it will be a positive cos x. Yes, so is that fine? Now what we need to do, yeah, so integration of cos x will be plus sin x, sorry, so it will be plus sin x, and integration of sin x will be minus cos x, so this will be minus sin. Yeah, so what we need to do, we need to put alternate sign here, that is plus, then minus, and then plus and minus, and so on. Yeah, so what you need to see, you need to see here, uh, when you get matching term, you need to stop. Yeah, so if you see here, here is e to the power 2x cos x, right? E to the power 2x cos x, and here just ignore minus sign. Yeah, this minus sign, if you see here, here you got e to the power 2x and cos x, so this is matching. Yeah, this is matching. This yellow color, if you see, they are matching, so we need to stop here. Yeah, so what we are going to do now, see, same thing, we'll multiply diagonally, and let's write down. So integration of e to the power 2x, that is cos x into dx, we are going to write down, multiply plus and plus, so it will be e to the power 2x, that is sin x, plus, okay, now we are multiplying this minus and minus, so it will be plus, so it will be 2 e to the power 2x and cos x, and after that, because this is not going to be 0, this is not going to be 0, this is not going to be 0. So once it is not going to be 0, what you need to do, so once you got matching term, you integrate it again. So see, I'm going to integrate it again, so just multiply this here. So we are going back, so we can put here integration sign. So this bit and this bit I'm going to integrate again, so let's write down here minus, it will be 4 e to the power 2x and cos x. Yeah, so we need to integrate again this one, so this is the new rule. So I repeat, when it is not going to be a 0, so you need to look for a matching term. Once you got the matching term, so when you are writing diagonally, like e to the power 2x into sin x, that we have done, 2 e to the power 2x minus cos x, and this minus minus turn into positive, that we have done, and then we are moving backward and we are going to integrate it again. Yeah, so this will be this we can write down, e to the power 2x. Yeah, e to the power 2x, that is sin x, plus 2 e to the power 2x cos x, minus 4 you can write down outside, so e to the power 2x and cos x. Yeah, so now you need to pay attention. If you see, this is e to the power 2x and cos x, right? And here also e to the power 2x cos x, that is equal to, so suppose this is equal to I. Yeah, so let's suppose this is equal to integral I. So let e to the power 2x cos x is integral I. So this will be I equal to this, so it is I, and it will be e to the power 2x sin x plus 2 e to the power 2x cos x, and this we can write down minus 4i. So if we do plus 4i both side, if we do plus 4i both side, plus 4i here and plus 4i here, so what we will get, we will get 5 here, 5I here, and it will be e to the power 2x sine x plus 2 e to the power 2x and cos x. Okay, nice and easy. So our final answer is it is equal to 5I. So what will be I? I will be 1 upon 5 e to the power 2x sine x, and it will be 2 over 5 e to the power 2x and cos x. Yeah, so this will be your final answer, and we'll put one constant here. Okay, we'll put one constant here, so e to the power 2x cos x. Yeah, that's it. So quickly, so this is our final answer. Yeah, this is final answer. So let's see another question, that is integration e to the power x into cos x into dx. So what we need to do, just write down here d, and here it is I, and just draw a line. So different e to the power x here, this term, and cos x you write down here. Now what we need to, so derivative of e to the power x will be e to the power x, and cos x integration will be sine x. Yeah, so this is sine x. Then again derivative, it will be e to the power x, and sine x derivative will be sine x integration will be minus cos x. Yeah, so let's put sine, alternate sign, plus, minus, and plus. Yeah, so what we need to see, we need to see matching term. As I told you, we need to look for matching term. So here matching term, if you see here, e to the power x cos x. So let's make it yellow. Here it is e to the power x cos x. So here also e to the power x cos x. Just ignore minus sign. Yeah. So what will happen here? So e to the power x cos x dx will multiply diagonally, this into this and this into this, and after that we will move backward here. So let's write down, it is plus and plus, so it will be e to the power x sine x plus, now we are multiplying this minus and minus, so minus and minus becomes plus, e to the power x cos x, and after that one, because this is our matching term, so we need to move back and we integrate it again. So we are putting just integration sign here, integrate again. So which sign is here? Minus. So let's write down here minus sign, then integration sign, and e to the power x cos x into dx. Yeah, now what we are going to do, let capital I is e to the power x cos x. So this side we can write down, so this will be I, so this will be I equal to e to the power x sine x e to the power x cos x, and this is minus I. So once you are doing plus I both side, once you are doing plus I and plus I both side, so it will be 2I e to the power x, you can take common, so it will be sine x plus cos x, and we can put one constant there if you want, because it is a indefinite integration, and then I will be e to the power x divided by 2, and it will be sine x plus cos x and plus constant. Yeah, nice and easy. So this is the way we can solve these questions in a quicker way. As I'm explaining these questions, it is taking time, but you can solve it, I think, within a 1 minute. Okay, let's see a couple of more questions. So here is the question, x3 ln x. Yeah, so if we take derivative here and integration part here, and we'll do it. So if you take x3 here, yeah, and ln x here, so we don't know integration of ln x. right? We don't have any formula to calculate Linux integration. If you need to integrate Linux, then you put linux.1 and then integration by parts. That's what we are doing. So here is the problem. So in this situation, what we need to do, we can just swap here. We can swap and write down this side Linux because we know the differentiation, and this side is xq. Yeah, now differentiation of Linux will be 1 over x, and here integration of x3 will be x4 over 4. So because we have swapped here, so here is a new rule, that is the third rule. When you should start getting a smaller value here, yeah, especially when you start getting a smaller value, you need to stop. So remember, you need to stop when you get stop. So here log x, so as we differentiate it, we got 1 upon x, so we are getting a smaller value, so we need to stop here, right? Is that clear? So we need to stop here. So, and then this is alternate sign, don't forget to put plus and minus. So how we are going to do it? So integration xq log x. So let's take this term first. Yeah, so it is plus and it is plus. Yeah, so it will be x to the power 4 linux. Okay, then we need to move backward again and then integrate. So move backward and then integrate. So I'm putting integration sign, move backward and integrate. So because there is a minus sign, so then you put minus sign here, integration x4 over 4, this yellow term x4 over 4 you write down here, and then this 1 over x you write down here, and this minus sign you have already put it here. So x4 over 4 dot 1 over x dot dx. So this will be x4 over 4 ln x, 1x cancel, 1 over 4 is outside, so integration xq into dx. Yeah, so if you integrate it, so it will be x4 over 4 ln x minus 1 over 4, and integration of x3 will be x4 over 4 and plus constant. Yeah, so this is your answer. Here you can simplify, it will be 16. Yeah, so this is your question. So in this way, so this is the third rule. When we cannot take log x here because we don't know the integration of log x, so we need to swap here. Once we need to swap, so when this derivative part is getting smaller, then you need to stop. So here 1 upon x is smaller than this, so we need to stop and then follow the same thing, and then in the last step you are going backward and do the integration. Okay, so this is the way you need to do it. So I hope guys you must have enjoyed these tricks, as I have taken long time to explain this. Once you have understood and you will apply those tricks, you will take less than 1 minute here. So that's all for today, and we will do couple of questions in next video. Till then, goodbye. Thanks for watching.